So we're going to go over another completing the square review for today, and our first directions is to complete the square, graph the parabola, and then describe the transformations from the parent graph. So we always start completing the square in the same way. We're going to set up the problem. So we're going to add a blank on the left side. We'll add our own blank on the right side. And we traditionally assume that C value is incorrect, so we move it over. Now what we notice on this one right away is that leading coefficient is not a 1, so we are forced to factor that out as our next step. So y plus a blank would equal 4. Now what that means, if we're going to factor out the 4 from all of the terms, means we're going to go and divide those terms by 4. So 4x squared divided by 4 would leave us with x squared. Now unfortunately, when we divide that b term by 4, it's not divisible, so we have to leave that as a fraction. And then we don't know what number we are going to add yet. So now we're going to calculate our b value in b over 2 and b over 2 squared. So our b value is 5/4. So if I divided that by 2, I would take 5/4 and divide that by 2. But instead of having a fraction divided by a number, we can take 5/4, and instead of dividing by 2, we can multiply by its reciprocal, which gives us 5/8. So then if I wanted to figure out my b over 2 squared, I would take 5/8 and multiply it by itself, and I would get 25/64. So that will be the number that completes my square. Now we know the most important part of when we complete the square, when the a value isn't 1, is making sure we add the right number to the left side. So I actually added 4 groups of 25/64. So I need to figure out what is 4 times 25/64. And I'm going to do a little reducing first. The 4 and the 64, I could divide both those terms by 4. So that'd leave me with 1/16. And then the 25 is still there. So that would leave me with 25/16. So that is the number that completes the left side. Now from there, again, the whole reason that we decided to use the number 25/64 was that we could factor this into a perfect square trinomial. So we're going to continue factoring that perfect square trinomial. So I'm going to leave the left side as y plus 25/16, and the right side should equal 4, and then in parentheses, we know how this factors. It always factors into x plus b over 2 squared, and then there's the plus 6 at the end. So for us, we know our b over 2 value was 5/8. So instead of calling it b over 2, I can replace that with its actual value of 5/8. Now my last step is to get y alone, so I'd have to subtract 25/16 from both sides. So we're working on our final answer. We get y is equal to 4 times parentheses x plus 5/8 squared, and I just need to quickly figure out what is 6 minus 25/16. So 6/1 minus 25/16. I would need to get a common denominator of 16 for both of these. So that would give us 96/16 minus 25/16. And when we complete that math, 96 minus 25 will leave us with positive 71/16. And that is our vertex form. So we do need to make a graph of this and describe the transformations. So I'm just going to recopy my vertex form so I can better describe what the transformations do. And I'm going to do those transformations in green so we can easily tell our work. So this 4 is going to vertically stretch our parabola. Because there's a plus sign in with the x, this is going to move it left 5/8 of a unit. And then the plus 71/6 at the end will move it up that many units. So if we go and construct our graph, again, I'm not worried about the scale. I just want things to be in the correct quadrants. So if I go graph the vertex first, it should be at negative 5/8, positive 71/16. And that's somewhere in this quadrant, and that's all that I would expect. So with the y-intercept, I'm actually going to move that down just a little bit. It's a little too tall. Now with the y-intercept, I have positive 6. And 71 divided by 16, just so we have a frame of reference, is about 4.4. So my y-intercept of 6 is going to be above it. So this is the y-intercept of 0, 6. If I know where the vertex is and where the y-intercept is, I can always find its partner. So this is 5/8 away on the right. So I'd travel 5 more eighths, which would bring me to the point 10/8, comma 6, negative 10/8. And then we could obviously reduce that by 2 to negative 5/4, comma 6. Either one of those would be fine. And we're done with that problem. So moving forward, now the next example we have to do is convert from vertex form to standard form, make a graph, and then describe the transformations. So the transformations are actually done easiest in vertex forms. We're going to describe the transformations first. So with this first one, the -3 inside parentheses should move it right 3 units, and the +6 at the end should move it up 6. Those are the only transformations. So if we're going to convert it to standard form, we always start by expanding the squared term. So we can multiply, so x times x is x squared minus 3x plus 9, and then we still have the +6. So after we combine our like terms, x squared minus 6x plus 15. That is our standard form. So I'm going to make a quick sketch of that graph just like we've been doing. So I should be able to plot the vertex because I have vertex form. Now that vertex moved right 3 and up 6. So I'm going to put that point right there as 3, 6. The y-intercept is easily seen in standard form as 15. So this is the point 0, 15. And if I know where the middle of my parabola is, I can always find the partner. So this y-intercept was 3 away on the left. So its partner would be 3 away on the right, which should be the point 6, 15. We've created a sketch of our parabola. Moving on to number 3, we are going to describe the transformations first. So the negative is going to cause this to flip over. Now whether I'm facing up or facing down, that 2 is going to vertically stretch it. We can ignore the positive or negative. We're trying to talk about stretches or shrinks. Because there's a +1 in parentheses, that's going to move it left 1 unit. And then the -4 is going to move it down 4 units. So to convert it to standard form, we always start by expanding the squared term. And then as we recommended, we should always multiply the polynomials first. So I'm going to leave the -2 there. So I'd get x squared plus 1x plus 1x plus 1, and then there's still a -4. Now we distribute the -2, so we get -2x squared minus 2x minus 2x, and then -2, and then there's still the -4. So at the end we can just combine our like terms. So -2x squared minus 4x minus 6. And that is our vertex form, or excuse me, our standard form. So we can now make a graph of this. We know the vertex has been moved left 1 and down 4 units. So I'm going to put that right here at -1, -4. The y-intercept should be at 0, -6. And I can find its partner point by finding the distance to the axis of symmetry. That was a distance of 1, so I'd travel 1 more. And that would bring me to the point -2, -6. And we've created a sketch of our parabola.